Hey guys, Ruth here, back at it with another printer video. So this is on the printer upgrade. So this is the current configuration. And that's the bed, and this is the gantry, and then the Z-axis. We're moving down. Nice smooth. This is slightly harder, but it's because of the constraint here. I've constrained it here and here. Remember not to move. This one I've constrained it here and here. This one I've constrained it here and at the motor to the back. So I was watching some YouTube video. Need to like. So max imagination. Coming to the upgrade. Let me save. So this is a rough idea. The previous video, the bed was moving up and down, but it tends to become tricky moving heavy parts, and because of the balance, you can't printing on one side, it's roughly hard. So I've upgraded to this, moving the gantry. I'm using a lever mechanism, and as always I'm using threads. So this one is free, it moves freely, but this one will be constrained. Moving it far will be constrained. I'll place a motor here. Which will have a thread through this one. So as it moves along the X, it moves the gantry. There are two forms of amplification. The first one is the screw, using a screw to drive linear motions. There is a form of amplification. The second amplification is using a lever. The lever is not it's slightly offsetted. From this circle to this circle is roughly 90, and from this circle to this circle is roughly 140 millimeters. So the beauty about it is this moves a total of 30 from this point, from here to here. Let me show you. Can take distance, measure this and this. It brings up 50.6, and when you move it at the end, I'm getting a distance of 89, so that's roughly 90, 50 to 90, that's 40 millimeters. It's moving 40 millimeters, and then from there you take here, distance from here to here. It's 40 mm. I've constrained it because of losing parts. So 40 mm, and then when it's fully extended, After I'm making it to push this way when it's going up, because the force is going up. When it's fully extended, I'm getting it's 212, so 40 minus 212 comes to 170. It's moving roughly 170 mm. That's the maximum, because this spot, the extruder is touching the bed. So yeah, it's roughly 173 mm on the z-axis. So that's the z. The z is the one, and then now I have several constraints. This here, it's placed here. So this circle, since it's the center point, goes through to this one, and then this one has been constrained to this plate. I'll add a mechanism to hold it into place. This helps it not to move sideways. So the only motion that is available is only linear motion. These are constrained to here, this is constrained here, and then this is constrained here. So yeah, that's it. 40 mm pushing 170, from 40 to 170. So my steppers will have less work pushing longer distance. So that's for the Z. For the X, it's the same. The stepper is here, as I showed you. I want to move it, so I won't touch the bed. I'll only improve this. I'll remove this. I'll use this setup, and then have holes here and holes here, and then have that caliber mechanism. I'll remove this. I'll make it look like this. I'll push it to the back and move it from the top, push it to the back, so that it becomes the support for the rails. So the other second advantage is these rails at the moment I'm using two. Currently I'm using one. The main upgrade is to remove this, because I can't print past this. I can only print roughly 100 mm. Past that, the part going past above this point becomes tricky. So yeah, I will do. There's a rough estimate I've done to approximate the length moved from one point to another point. Yeah, there's a high probability it's not linear, because it's not linear. Yeah. So yeah, I'll do the math a bit later. That's it. Thanks for watching. Please do share, like, and subscribe. Thank you.